This video is about using information to create a system of equations. So we're going to use the information to set up our equations. We're going to have two equations for a system of equations. So in number one, it says Alex and Bailey are working together on a design project. They have been allowed a total of 7 hours to work on the project and will make $151. Alex makes $18 an hour and Bailey makes $23 an hour. So first we want to read and see what's going on. So we know that they are making a project and they have a total of 7 hours to work for a total of $151. So what are our variables? Well, we're trying to figure out how much work each person's doing. So when I'm doing my variables, I can pick X, Y, I can pick whatever I want. So in this case, because I have two people named Alex and Bailey working, I'm going to use A and B. So I'm going to say that A is going to be Alex hours worked, and B is going to be Bailey hours. So now I need to write a system of equations. So remember, a couple seconds back, I underlined 7 hours at $151. So I know that they are working a total of 7 hours. So I don't know how much each person's working, but together they are working 7 hours. So together, if they're doing something, we want to add their hours. So one equation is going to be equal to the 7 hours, and one equation is going to be equal to the $151. So we have A plus B equals $7, 7 hours. Because the hours Alex works plus the hours that Bailey works has to add to 7. Then we also have something with $151. So we know that it has to be equal to 151. We can't do A plus B equals 51 because A and B are representing hours. So we need to add something else into the equation. We'll look at, they told us that Alex is making $18 and Bailey is making $23. That's going to help us with this equation. So if Alex is making $18, we're going to say 18A. For every hour worked, we're going to multiply that by 18 plus 23B equals our $151. So now we have our two equations, and we'll learn in the next couple of days how to solve those. Today we're just working on setting things up. Number 2, James and Tucker are taking a road trip. They drove a total of 9 hours and have traveled a distance of 555 miles. James drove at a rate of 55 miles per hour, and Tucker drove at a rate of 65 miles per hour. How many hours did James and Tucker drive? So our variables in this case, we're going to use J for James hours and T for Tucker hours. Now, if we go back and look, we saw that they drove for a total of 9 hours and covered 555 miles. So we're going to have two equations, one set equal to each. So if we know that our variables are representing hours, we can say J plus T is equal to that total of 9 hours. Now in the last equation, to get that second number, which is bigger, we couldn't just add the two variables together, we had to add coefficients. So before we added how much money they made, this time we're going to say how fast they were driving to multiply by the hours. So James was driving 55 miles an hour, so we have 55J, plus Tucker was driving 65 miles an hour, so 65T. In number 3, the sum of a small and large number is 22, and 2 times the large number minus 3 times the small number is 46. So in this case, they're giving us two sentences that have our equations in them. So first we need to identify the variables. We're trying to find the small and the large number. So let's use S for small number and L for large number. Now, each sentence is telling us something about our equation. So we have the sum of the small and large number is 22. So remember that the word is always an equal sign. Remember that sum is addition. So if we add those two numbers together, the small number plus the large number, it's going to equal 22. The second sentence then tells us 2 times the large number minus 3 times the small number is 46. So is 46, we know it's equal to 46. 2 times the large number, so we're multiplying 2L minus, so subtract 3 times the small number, so 3S. And then later on we would go on and solve this. Number 4, a swimming pool has a perimeter of 124 feet. The length of the pool is 10 feet less than 5 times its width. What are the length and the width of the pool? So if we have a length and the width of the pool, it's going to be a rectangle pool. So remember, we're going to have 2 widths and 2 lengths. So we're going to say that L is equal to the length of the pool and width is going to be W. So perimeter, remember with perimeter, you're always adding the sides of your shape up. So we're going to combine like terms in this case. So we have 2 L's and we have 2 W's. So we're going to say 2L plus 2W equals the perimeter of 124 feet. Then we have this sentence that gives us a relationship. The length of the pool is 10 less than 5 times its width. So the length is. So whatever's before is going to be on one side of the equal sign, and whatever's after is on the other side. So the length is L equals 10 less than 5 times its width. So let's go backwards here. So first we have 5 times its width, so we're going to have 5W, and then less than. So we're subtracting 10. Number 5, a group of tourists are taking a boat tour of Chicago. There were a total of 23 tickets sold for a total of $309. The cost of an adult ticket is $15 and a children's ticket is $9. How many of each type of ticket were sold? So there's 2 types of tickets of people that are going on the boats. We have A for adult, we have C for children. So we know that there was a total of 23 tickets sold for a total of $309. So our first equation we're going to say is equal to 23 because whenever we have a total, it's equal to that. So to get 23, we have to know how many adults and how many children are together. So we're going to add A plus C and set it equal to 23. Then we also have this total of money, $309. So again, we can't just do A plus C. We have to include, because it's money, how much each ticket is costing per that person. So for an adult, it's $15, so we would have 15A. Plus, for a children's ticket, it's $9, so we would have 9C. Number 6, the sum of a small and large number is 186. The large number is 6 more than 3 times the small number. Find the large and small number. So if we're finding the large and small number, we're going to say that S is going to equal our small number, and we're going to say that L is going to equal our large number. So in this problem, we have 2 things they tell us. We have what the sum is for one sentence, and for another sentence, it tells us how those 2 variables relate. So in the first equation, it says the sum, which remember is addition, is 186. So we're going to add those variables together. S plus L is equal to 186. And in the second equation, it says the large number is. So remember, is going to divide those 2 sides of our equation. So we have the large number is, L equals 6 more than 3 times the small number. So let's work backwards. 3 times the small number is 3S, and then 6 more. So this time it's more than, which means we have to add to it. So plus 6. Let's look at one more problem. So number 7, the Morris family is at the movies for a family weekend. They decide to stop at the concession stand for some movie snacks. The family bought twice as many boxes of candy as they did popcorn. Each box of candy costs $1.79, and each popcorn bag costs $4.95, and they spent a total of $25.59. How many boxes of candy and popcorn did they purchase? So our 2 variables here are C for candy and P for popcorn. Now, in this problem, they give us 2 different things. They give us a sentence that relates the variables together where we have they bought twice as many candy boxes as they did popcorn. Then we have the sentence with the total. So one of our equations, we need to show that they bought twice as many boxes of candy as they did popcorn. So when it says twice as many boxes of candy, that means candy is going to be the more variable. So we're going to say that C equals, and we need twice as many as popcorn. So for example, if we bought 2 popcorn, we would buy 4 candy. So we would show 2p. We're taking whatever popcorn we buy and we multiply it by 2 to get the number of candy boxes. Then our other equation, we need to figure out how to equal the total money they spent. So we know that they spent $25.59. So we have to add the cost of the items together to get $29.59. So we know that a box of candy is $179, so we have $179C plus how much they're spending for popcorn, so $4.95, and that will equal the total they spent at the concession stand. Now, number 8 is a little bit different. It doesn't have a word problem. It's got a picture that we need to make an equation with. So when we're doing an equation, notice that we have one line, that's the whole length, and then we have little lines that are chopped up into pieces. So remember that the little pieces, when we add them together, are going to get us the whole line. So in the first equation, we would just take those 2 variables that are different, we would add them together to equal our total length. The second picture is a little bit trickier because there's 3 different parts. So we're just combining like terms still. So we have an x and an x, which would get us 2x, plus we have 3y, and that's going to equal our whole piece, which is 42.